Welcome to today's webinar about display integration in practice. My name is Niklas and I work as a project and design engineer here at Webpoint. In this session, we'll look at displays not just as separate components, but as part of the complete HMI solution. I'll share some practical considerations that can help make display integration easier from the start. Before we begin, a quick practical note. You can feel free to write your questions as we go along in the Q&A session here in the webinar. I'll answer as many as possible during this session at the end of the presentation. If there are some questions that I cannot answer directly here, we'll make sure to follow up afterwards by email. We'll go through three main areas today. First, we'll look at the display as part of the complete HMI. Then we'll look at how the application defines the right display choice, because the best display is not always the most advanced one. Finally, we'll look at 6 practical construction examples showing different ways to integrate a display into an HMI solution. In many cases, we see that displays are handled as a separate component to a keypad. It might not be a challenge to source the display, but integrating it with the keypad next to it might introduce some challenges if not considered from the start. We believe that we can simplify this process for you if we have this dialogue together at the start of the project and take care of the whole HMI instead of separate components one at a time. This provides a smoother development and production process. Let's have a look at what we offer. As we see it, our task is to simplify both the development and production of your HMI solutions. When we are part of this process, we take responsibility for the entire tolerance chain, where we'll take care of the physical and technical integration between the display, the keypad, potentially also a touch functionality, and other mechanical considerations regarding the assembly. As our focus is on integrating different components mechanically, you can focus on preparing the graphical user interface and other software. When the product is finalized, we'll also assist with compliance and lifecycle engineering. Now, let's look into the sourcing of displays. When we talk about displays, it is important to say that we are not a display distributor in the traditional sense. We source displays as part of an integrated HMI solution. That means we help find a suitable display based on the application, and then we look at how it needs to be customized and integrated into the complete construction. In many cases, the display will be selected from a standard portfolio, but there can still be relevant adaptations. For example, cover glass size, brightness, temperature range, interface, cable position, or other application-specific requirements. So the process is usually to start selecting the right display from the beginning, adapt it to where needed, and then integrate it with the keypad, touch function, front layer, and mechanical assembly. So how do we choose the right display? The starting point is not the display itself. The starting point is the application. There are a few practical questions that are useful to ask early in the project. What does the user need to see? Is it a simple text, symbols? Do you need graphics, or colors, or dynamic information, or visual feedback? Where will the product be used? Is it an indoor use, outdoor, in direct sunlight, in cold or hot conditions, or in demanding industrial environments? How will the user interact with the product? Is it by a keypad, a touch display, touch buttons, or a combination? Which technical requirements define the display? Here we look at the size, the active area, the resolution, the brightness, temperature range, interface, and viewing angle. How will the display be physically integrated? Here we consider the sealing, assembly, tolerances, EMC or ESD shielding, the cables, bonding, front panel, and housing are also to be considered here. For the next couple of slides, I'll go through some of the major types of displays. The first display is maybe also the simplest to program, but also offers the least amount of customizability. It's a character LCD with simple monochrome text that allows for simple information to be shared. The pros are that it has a low cost, easy to use and integrate, it has a low power consumption, it's good for displaying text and numbers, and then it has an availability between different range of backlight colors. The cons are that it has a limited graphics capability. It has a low resolution, and it can only display a small amount of information at a time. And to some, it also might appear outdated compared to modern displays. The next display is a segment LCD, which is often used for displaying simple numeric or alphanumeric characters. It allows for custom icons that can be turned on or off and relies on segments of characters to be controlled via a simple on and off pin connection. The pros are that it has a very low cost in production. It's excellent readability at a distance. It has a low power consumption, fast response time. It's easy to control with simple electronics, and then it's quite reliable and durable for industrial environments. The cons are that it's limited to changing numbers and simple characters. It cannot change graphics once it's produced, and it always requires a custom display setup. Then we moved to a more customizable offering with the graphic LCD. It's a monochrome display that has variable sizes and resolutions available and offer different backlight color options. The pros are that it can display graphics and icons and animations. It has more flexible UI design than character LCDs. Then it supports custom fonts and symbols, suitable for richer user interactions, and has also the availability for RGB backlighting. The cons are that it has a higher complexity than character LCDs, and that requires more memory and processing power. It comes at a higher cost and requires more demanding software integration. Continuing with the monochrome offering, we have the e-paper display, which is an ultra-low power display that only requires power when it needs to change the graphics. The display will keep the information viewable even if power is not on. The pros are that it has an extremely low power consumption, it's excellent readability in the sunlight, it has wide viewing angles, and has a paper-like appearance that reduces eye strain. It retains image without continuous power. The cons are that it has a slow refresh update speed. There's a risk of burn-in if the same image is displayed over a long period of time. Then there's a limited color support. It has poor suitability for animations or video. And then it's more expensive in some sizes than compared to simple LCDs. The TFT display is the first full color range offering and is commonly used in modern HMIs. It's also the type of display that is in most computer monitors, for example. The pros are that it has a full color with high quality graphics. It's responsive and provides a smooth user interaction. It supports complex graphical user interfaces and animations. It has a wide range of sizes and resolutions. It's suitable for touch integration and also has a modern appearance. The cons are that it has a higher power consumption. It can be more expensive than simple displays, requires even more processing power and memory. Then it's also depending on more complex software integration. And in some models, there's also a reduced sunlight readability. The last display that we'll highlight in this session is the OLED. It's a more exclusive offering than the TFT display. With its self-emitting pixel backlighting, it's possible to achieve perfect blacks, which makes it possible to only show the information needed without a backlight frame surrounding it. The pros are that it has an excellent contrast and deep blacks. It comes with wide viewing angles, it's bright and vibrant in its colors. Then it's quite thin and compact in its design and has a fast response time. The cons are that it has a higher cost than LCDs. There's a risk of burn-in over time. Brightness can degrade with age and has a shorter lifespan in demanding environments. And then it's also more sensitive to moisture and heat. I'd like to add to this list that there's no right or wrong choice for any use case. It's about your needs and requirements for your specific situation. Now that we have looked at the main display types, the next step is to fine-tune the display choice for the specific application. There are two tracks we can take here. The first is what we can select or customize from the display side. And the second is what we can solve through the HMI construction. From the display manufacturer, we can, for example, source a round display, a flexible display, a certain touch technology, or display with a wider temperature range. Other requirements are not necessarily solved by the display itself, but by the way we design the surrounding construction. For example, if the HMI needs to be more rugged, it needs to be easier to clean, optically bonded, shielded, or integrated into a specific front panel or housing. So now let's have a look at some of these construction options. These examples are not the only possible solutions, I'll also like to add. but they represent some of the most common principles we see when the displays are integrated into HMIs. For these examples, we've kept it relatively simple and easy to compare with the same building block. Here we have the front layer, that could be a foil or a cover glass, or maybe a silicone. Then the ceiling itself, which typically is an adhesive or a glue. Then of course the display itself, a source of input, which could be metal domes or a touch surface. And then finally a fixation to the housing, which we normally see as a rear adhesive. Sorry. The list of components that we can integrate into is quite long. There's different component options such as speakers, light sensors, RFID tags, encoders, status LEDs, and so on. When these elements are considered together from the beginning, it becomes easier to manage space, ceiling, cable routing, assembly, and the interface to the main PCB. So now let's have a look at the first example. This first example shows one of the thinnest HMI constructions. Here, the display is integrated behind a flat front layer together with the membrane keypad. This gives a very low profile design with no gaps between the buttons and the display area. That makes the front easy to clean and suitable for products where sealing, durability, and a slim construction are important. This type of solution is often relevant in, for example, medical devices when the user needs clear function keys, but where the overall front should remain flat, robust, and cost efficient to produce. This example is relevant when the user needs clear tactile feedback. Here, the silicone buttons make it easier to locate and operate the keys by feel. That can be important if the product is used with gloves or in low visibility conditions. Silicone also gives more freedom in the button geometry. In this image, the buttons are flat, but with silicone, you can of course shape the buttons as you wish. You can make them in different shapes or raise them even higher to improve usability. The front layer can be combined with a foil, but could also be replaced with a cover glass, depending on the design and protection requirements. In this next example, the display is protected by a cover glass, while the user operates dedicated tactile buttons placed next to the display. This can be useful when the display needs a robust and easy to clean surface, but where key functions should still be operated with physical feedback. The button layout can also be adapted to different product versions. For example, in this case, one version may have 3 buttons, while another has 5, without changing the overall display concept. The next example uses silicone as the main front element. One advantage is that the display can be recessed into the silicone construction, which gives extra physical protection around the display area. The silicone can also be designed with different levels, raised areas, or protective edges, depending on how the product will be used. This can be relevant in applications where the HMI is exposed to impact or demanding environments, and where the product benefits from softer, more protective front construction. The next example here combines a touch display with fixed touch buttons around the active display area. The touch screen gives flexibility in the user interface. The dedicated touch buttons give fast access to main functions. One thing to be aware of is that this solution requires a touch display in itself, so the display selection becomes more specific. A benefit in this type of construction is that the display and touch function can often be connected through a simplified cable setup to the main PCB, depending on the design, of course. It also gives a clean, flat front with fewer mechanical openings, which can be useful for sealing, cleaning, and visual design. The next example is a good alternative to the example before. Here we have sorry. Instead, a separate capacitive, sorry, I'll just start from the top for this one. This example is a good alternative when the display itself does not need to be touch enabled. Instead, a separate capacitive touch foil is integrated between the cover glass and the display. That means the display choice remains more open because the touch function is handled in the HMI construction rather than inside the display. This can be a cost-efficient solution compared to using a full touch display, especially if the user only needs a limited number of touch functions. So to sum it up, display integration is not only about choosing the right display. That is an important part of the process, but the display also has to work together with the rest of the HMI. The keypad, touch function, front layer, sealing, cables, housing, and mechanical assembly. So the main takeaway from today is, do not treat the display as a separate component for too long. Think of it as a part of the complete HMI from the beginning. This can help reduce sourcing complexity, design risk, assembly challenges, and future replacement issues. Right, so now let's go to your questions. I'll just stop this presentation here. So does anybody have any questions for what we have presented? Or maybe you have a specific need that you have an overall question for? Okay, so I'll just take this first question here, and you can correct me if I maybe misunderstand your question here. But as I see the question, what about soft touch backlit buttons on a flat surface? I consider this as a silicone keypad, right? Which is a part of the HMI, and that can also be possible without lifting the button area. We can also make a flat surface for the silicone front, and then have this backlit functionality in the buttons itself. So yeah, that's also definitely possible with the soft touch silicone in a flat surface. So there's also a question here regarding the temp specifications, and it's of course depending on the size you need and the specific use case. Normally we see the temperatures being from -30 to 70 degrees, but we also have some extended temperature ranges that can also go to 85 or maybe 90 degrees. But that's a little bit special use case. We also have a question here regarding MOQ, and normally we don't really have any recommended amounts. We can make 5 displays if that's what you want, or we can also make 100 or 1,000 or even more. But of course, prices depend on the MOQ that you need. So if you have a small project, that's possible for us to solve and look into. But also, if you have a very large project, we can also discuss that with you. Okay, so we have a follow-up on the first question here. Yeah, so we can make touch areas that also have a dead front effect. Normally we would do this in the cover glass or the membrane keypad in itself, and then use the LED layer underneath to make this backlighting possible. But as the touch layer is transparent, that's easy for us to light up through this layer. So yeah, we can make touch areas with dead front effect. So I think if you're considering right now whether if it's a good price or not for the different displays, I think we need to have it specific dialogue on what your needs are, and as you also maybe gathered from the presentation, it's not just the display, it's also the combination of the whole HMI. So discussing prices right now is a little bit difficult, but please feel free to reach out with the specific request that you are currently considering. Then there's a question regarding a curved display. I'm not sure if I can fully reply to it regarding what you intend to ask here, but we do have suppliers that can deliver a flexible display or curved display in specific standard solutions. If it's a dot matrix or not, I have to look into that at a later point. So there's a question here about whether it being done in mold or not. I'm not sure I understand the question fully. If it's regarding silicone, then we can maybe direct you to another webinar that we also held regarding the silicone shaping and the possibilities regarding this. But if it's a membrane keypad, then it will be done in different screen printing processes to make this different effect. I hope that's enough. Otherwise, please feel free to reach out again. There's a follow-up question here, I think, to prices, and I'll have to repeat myself a little bit because it's very dependent on the specific situation that you have and the materials and types of adhesives and so on. So giving a cost estimate in this webinar is not really possible. So Marcus also have a quite good question here for rules of thumbs. This being specifically about the adhesion around the display. And for sealing purposes for IP67, we have a rule of thumb for 5 millimeter adhesive gasket. So if you have space for 5 millimeters around the display, then that should be sufficient. So there's also a question here about integrating antennas, and yes, we also integrate some antennas in some keypads. Normally, this would be as part of a PCB or an FBC in the underlying layers, but can also maybe be a separate component if that's what you need. So there's also a question about the MOQ for samples. Our normal quantity is about 10 pieces for prototype productions, but we can also supply one piece of a specific display that you intend to use for the HMI, and then we can discuss the display functionality by itself, and then move further in the development with the rest of the HMI afterwards, and produce a full 10-piece prototype. Okay, so I think I'll end the webinar here, and I'll just hope that you had some effect of listening to this. So thank you for joining. If you have a specific project or application where display integration is relevant, you are of course also always welcome to reach out, and we'll be happy to discuss the options with you. Okay, so have a nice day.